Hi everyone, this is Maverick Paul, the chemistry guru. Now in this video, we want to discuss the suggested solution for 2021 A-Levels H2 Chemistry Paper 1 question 23. Now question 23, compound X reacts with lithium aluminum hydride to form a compound with molecular formula C6H13N. It also reacts with warm HCl aqueous to form a salt with formula C6H14NO2Cl. So what could be the identity of X? We have four options A, B, C, D. All the functional groups here are involving amide functional group. So what we will have to do is we will have to consider the reaction for each of these options with lithium aluminum hydride, see whether the molecular formula is consistent with whatever that is given in the question. Ideally, we will be able to eliminate some possible options, and the remaining options, we will handle the next reaction involving acidic hydrolysis with HCl to see which one of them will give me this salt with this specific formula. So the topic tested in this exercise obviously is under nitrogen compound targeting amide functional group. And what we have to do is we will have to consider each of these options, try to reduce it with lithium aluminum hydride, then we see whether we can eliminate some options first. So let us consider the first guy. Now, first reaction. Reduction with lithium aluminum hydride to form C6H13N. Involving A, I have cyclic amide, and reduction using lithium aluminum hydride. What we do will be, I will take away the oxygen, I'll break the C double bond O, removing one oxygen and putting in two hydrogen. So losing oxygen and gaining hydrogen is considered as reduction. We should be able to draw out the product pretty easily. If I consider A, I just remove the oxygen and then convert it to a CH2, your product will be something like this. If we work out the molecular formula for this product involving A, it will be C6H13N. This is consistent with our question, so this is one of the possible options that we will have to consider later. Now involving B, again I have an amide functional group with a cyclopentane here. And same thing, what we do is we just remove the oxygen, convert the carbon to a CH2. The product will look something like this. If I go and work out the molecular formula for this guy, this will also be C6H13N. This is also one of the possible answer that we will have to consider the second step involving hydrolysis with HCl. Now next, how about C? Now involving C, what I've done is I've drawn out a structure so it is clearer, it's easier for us to visualize the reaction. Instead of using the structural formula, it's better for us to draw out the specific compound. And if I consider my compound looks something like this, 6 carbon, long, straight chain 6 carbon, and I have an amide functional group attached to carbon position 1. If I reduce this guy, same thing, remove the oxygen, convert carbon 1 to a CH2, product will be something like this. If you work out the molecular formula for this guy, it will be a C6H15N. You notice the number of hydrogen is not consistent, so C will be eliminated because the first reaction will not give me the product that we want. Involving D, this is again an amide functional group. Again, the recommendation is it's better for us to draw out the structure, either drawing out the skeletal formula or you draw out the display formula, so it's easier for us to visualize the reaction. But the reduction, the idea is the same. You take away the oxygen, convert the carbon to a CH2, product will be something like this. I'll end up with a secondary amine. Work out the molar mass for this. It will also be C6H15N. Number of your hydrogen is not consistent with what the question wants. This means that I can eliminate our options C and D. I will reject these two guys. Then later, for the second reaction, I need to focus on compound A and compound B. Now for the second reaction, hydrolysis with HCl to form C6H14NO2Cl. Hydrolysis involving our amide is fairly simple. I just need to break the amide bond. I'll convert the C double bond O to an acid group. Now involving my amine, what will happen is when it's being hydrolyzed, by right, it should form an amine functional group, NH2. But because of the acidic medium, it will be converted to your ammonium ion, supposed to be NH3+. And since the Cl minus is there, it will form a salt. And I'll end up with this NH3+ Cl. Since this is a cycloamide, when you break this bond, you will form one compound. One end of it will be acid. The other end of it will be ammonium chloride. So based on this structure that we have, figuring out the product shouldn't be that much of a problem. It's a fairly simple acidic hydrolysis. And based on this compound that we have, I work out the molecular formula C6H14NO2Cl. So A is consistent with the option. Most likely A will be the answer. We just need to run through B, and we want to make sure that B is wrong. And let us talk about it here. Now involving B, I have amine functional group, and if you hydrolyze this, when you do acidic hydrolysis, I'll break the amine bond. And now you notice I have two different pieces. One end of it, this is the acid end formula for this compound, which is a simple molecule. This is an organic compound with an acid group. The formula for this guy, it is a C6H10O2. Now the nitrogen portion is actually ammonia that is being formed, but under acidic medium, this ammonia will be converted to ammonium chloride. So the nitrogen and the chlorine will be in a separate compound. This is your ionic compound, this is your salt involving ammonium chloride. Now notice the formula is not consistent with what the question wants, because the question wants me to form only one salt, and the formula for this salt is this big chunk here, 6 carbon, 14 hydrogen, 1 nitrogen, 2 oxygen, and 1 chlorine. Now what I have is I have two different products involving option B. When I do acidic hydrolysis, I'll end up with two different products. One is a simple molecule containing C6H10O2. The other one is my salt. This salt only contains ammonium chloride. So B is the wrong compound. B will be rejected. So based on these two reactions, we should be able to determine the identity for X. X should be option A. Alright, so that was the discussion involving this question 23. If you have learned something useful from this video, please give me the thumbs up, like this video, and subscribe to my YouTube channel for more weekly video lessons. That's all for now. I'll see you next week.